All right, let's look at example number 4. Below is a graph of students' walk from her house to school. Let's take a look at this graph. So it says the students walking from their house to the school. We have our x-axis down here at the bottom says time in minutes, and it's going up by 1. So 1 minute, 2 minutes, 3 minutes, 4 minutes, and so on all the way up to 20 minutes. Distance from home in feet is our y-axis. And looks like, let's see, 1, 2, 3, 4, 5 boxes gets us up to 10. So that means each box is 2, right? 2, 4, 6, 8, 10. Yep. 12, 14, 16, 18, 20, and so on. So each box is 2 on the y-axis, right? That's always important. The y-axis doesn't always go by ones, okay? All right, so let's answer some of these questions. Which variable is the input? Input is the x variable, right? So the x variable in this case is our time in minutes. So time is the input. That makes the distance from home, that's the y values, okay? That is our output. So we input the time, and that lets us know how far she is away from home, right? Okay, so number 3, for the input of 6, meaning time 6 minutes, at 6 minutes, I'll even put that to remind ourselves, at 6 minutes. That's what that means. For the input of 6, or at 6 minutes, what is the output, or how far from home? Okay, what is the output? The output is how far from home. So how far from home is she at 6 minutes? That's what we're trying to figure out. So I'm looking for 6 minutes on my x-axis. Here it is, and there is the point. So here's the point. Okay, let's make that a different color so we can see it better. Okay, here's the point. And that point, we need to find what the y value is, right? The output, how far away from home she is. Okay, so how far is she? Well, let's drag this over to here so we can see on the y-axis where we're at. So we're right there, which is 1, 2 boxes above 10. Remember, each box is 2, so this would be 12 and then 14. So it looks like she's 14 feet away from home. So that's what we're going to say. Make sure you have your units. So the units in this case is feet, right? So 14 feet away from home. That is our answer for number 3. Okay, so look at number 4. At what time was this student 20 feet from her house? 20 feet from her house, that sounds like the output, right? That sounds like our y value, okay? So we need a y value of 20 for that's what we're looking for, right? And it says at what time. So the input, x value. Okay, so they want us to know what is the x value when the y value is 20. That's what this means. What time was this student 20 feet away from her house? So let's take a look at that. 20 feet away would be right here on the graph. And I'm going to make a line that goes all the way across because we need to take into account all of the times that she was 20 feet away, right? So each x value here has a unique y value, but this y value 20 has more than one x value associated with it, right? She was 20 feet away when it was at this point right here. She was 20 feet away from her house when she was at this point right here. And she was 20 feet away from her house when she was at this point right here. So at 3 different times during this journey, she was 20 feet away from her house. That seems kind of strange, right? If she's just walking straight to school, why would she be 20 feet away multiple times? Wouldn't she hit 20 feet away and then just keep going? Well, maybe along the way, she didn't just go to her house, or she didn't just go to school. Maybe something happened. That's what we're going to look at in the next question. But before we do that, let's take a look at all these different time stamps, time values when she was 20 feet away. So in this one, she was 20 feet away at about a minute. Okay, so a minute in. Okay, a minute in. Okay, so we're going to say at 1 minute. Okay, so she was 20 feet away from her house at 1 minute. When else? She was also 20 feet away at this location here. Woo! Whoa. not what I wanted. Sorry about that, guys. I was holding down the wrong button. Looks like at 5 minutes, she was also 20 feet away from her house. And the last one looks like 12 minutes. Okay, so at all of these different times, she was 20 minutes away. Okay, so at 1 minute, at 5 minutes, and 12 minutes, she was 20 feet away from her house. Right? Is this a function? Why or why not? How can we tell whether something's a function or not? Well, the rules that we have is in order for a function or a graph, a table, an equation to be a function, it has to have a unique output for every input, meaning every x value has to have only one option for a y value. So how can we do that? Well, we do something that's called the vertical line test. And what a vertical line test means is I should be able to put a vertical line on this graph, anywhere on the graph. I should do any vertical line possible. Look at all these vertical lines. And all these vertical lines, every single vertical line I make should only touch the graph or cross the graph, which is the blue line, right? Should only cross it once. So every single one of these lines I'm making, I should only hit the graph once. I only hit it once that time, right? How about this? Only hit it once. Only hit it once. Even over here where it looks like I might hit it twice, only one time, right there. Okay? What about this one? Only touched it once. Only touched it once. Only touched it once. If that's the case, that means that each of these x values, okay, so like an x value of 2, only has one possible y value. Okay, it's right here, which is like 23 maybe. Okay. What about an x value of 5? Do I have 2 outputs for that? No, I only have one output, similar to this one. Okay, similar, but only one. If there was a point here on this graph that was like here, that would tell me that this vertical line touched it in 2 spots. If it touched it in 2 spots, that tells me that it's not a function. Why? Because the input of 5 had 2 different outputs. It had this output here and this output here. All right, so that would tell me that it's not a function. But I don't have that. That's not the case. There's not a single x value here that has 2 different y values. Okay, so this is a function. So we're going to say yes, because each x value has one unique y value, okay? Or each input has one unique y or output, okay? So describe the situation the student is doing while walking to school. This is something that interpreting graphs is something that you is important to know. So let's just follow along this graph and kind of see what this girl is doing. So she starts at home, right? That's 0. 0 means she's at home. She starts walking away from home, and she's walking until she gets about 1 minute in. She's 20 feet away from her house. Then she starts to slow down. Why do I know that she's slowing down? Well, because the graph has a slope. And remember when we talked about slopes back in previous units? Slope for a distance time graph is speed. So the steeper that the slope of a line is, the faster something is going. So notice this first section of the graph here, this first section here, which is all this stuff, she's going pretty fast because that's a steep line. And then she starts to slow down. So this line is less steep, but she's still going away from her house, right? If she's traveling in the positive direction, that means she's getting further and further away from her home, okay? Then something happens at this spot here. She reverses, and she starts going back towards her house. Now, a common misconception here, guys, is that this is a hill. This is not a hill, okay? A hill, she might be hitting a hill here. Maybe that's why she slowed down a little bit, because she's going up a hill, all right? So slowing down might mean going up a hill, but this is still going away from her house. So what looks like might be a hill on a graph is not a hill. It actually tells us where in what direction she's going. So not the elevation, it tells us what direction. If her distance from home is going smaller, so in this section right here, that tells me she's going back towards home. So maybe she hit this point here and she said, oh shoot, I forgot my Chromebook. Well, it's gonna be really hard to learn because everything's on the Chromebook, right? So maybe she hit this spot and she's like, shoot, I gotta go back home. And she starts walking back home at a faster rate. This is pretty steep, right? Then she hits this spot. What happens here? Well, between the minutes of 6 and the minutes of 10, she's not going anywhere. She's not going towards home. That would be in this direction. And she's not going, towards school is in that direction. Towards home is in this direction. She's not going either direction. She's just staying where she's at. Why would she just stay where she's at? Well, the only thing I can think of is maybe she hit a stoplight, right? A traffic light. And the traffic light's telling her to wait. She can't cross the street yet. There's a lot of traffic. Okay? So maybe that's what that is. Okay? Then she realized she's real late, right? She's got to get home and get her Chromebook quick. So she sprints home after the traffic light. She sprints home. She gets home and just grabs her Chromebook and goes, right? Because she doesn't stay home for longer than a minute. Between minutes 11 and minutes 12, she is already moving towards home. So maybe she called her mom in this spot here where she was just hanging at the traffic light. She's getting all nervous, right? So maybe she's sitting there and she's like, I gotta make sure my mom has my Chromebook ready the second I get home. So then she sprints home. She gets home and literally her mom just passes it off to her. And she's like, okay, boom, back to on my route to school. So now she's really, really going fast, right? She goes at the same rate, basically, right? She goes 20 feet in a minute, just like she did back at the beginning. But then she doesn't slow down when she hits the second part because she just keeps going, boom, and she makes it to school. And school looks like it's about 40 feet away, right? So now she's at school and she's just there, right? And this graph would probably continue, all right? And we keep going, she's just at school at that point. And then when she comes home, then the graph would start coming back down home at the end of the day, all right? So this is kind of how you would interpret a graph and kind of describe a situation. So let's put that down into words really quick. I know this video is getting long. So she started out walking to school, slowed down a bit when she realized she might be missing something. We don't know this. This is kind of just assuming, right? Just based on the graph. We don't know exactly what happened, but this could be something that happened. She realized she was missing something, started heading back home at minute 4. Sometimes it's nice to give these little things describing words at minute 4, right? Where did she start slowing down? At minute 1. Okay, so these are the inputs. We're kind of using those inputs to describe what's going on. And she realized she might be missing something. She did realize she was missing something. She started heading back in minute 4. She hit a traffic stop at minute 6 for how long? 1, 2, 3, 4 minutes. That's long traffic stops. And she sprinted home and made it there. Minute. This is a long explanation, right? But that's okay. At minute 11. Then hurried off to school. And made it there at minute. How long did it take? Minute 13. All right. So still, I mean, she must be real close to home. 40 feet. She's 40 feet away from school. So her home is pretty close to school. It really doesn't take that long. She got there and back. Then she got halfway there, back home, and then all the way there within 13 minutes span. So she must must be right down the street or something. All right, guys. Hopefully this helps. You guys have a check for understanding to work on, and I'll see you in the next lesson.